next step will be our CNN model. I will write the code, then I will explain because it was too lengthy topic. So proceed to model dot model is equal to sequential. Now model dot add, use the convert 2D layer and 64 filters, no 32 filters, and the kernel size will be 3 cross 3. And the activation function will be relu, and padding will be same, and input shape we are already shows that size, the number of image, size, comma 3 mean 224 cross 3, which means the RGB is used in for color images, and one right for grayscale. Now model.add max pooling, and the kernel size will be 2 cross 2. And now this is our first layer. The second layer will be editor, and this is the same as above, convert 2D, and the kernel size will be 16, and the filter size 16, and kernel size 3 cross 3. Activation function value, adding same, they are also same. It's not compulsory. You should write that filters. You should try to different filters like 64, 32, 96. Kernel size will different, max pooling different, or you should try average pooling. So they are the same. This is our second layer. Now we should copy that layer and first here and again, and change the filter size, and that also add. Now we have 4 layers, and that is the fifth layer. Now we should write the flatten layer, model.add flatten layer, and then now the dense layer, there will be write model.add and dense layer, and the dense layer will be there. We should think 126 filters, and activation will be relu. And now there we add model.add dense layer, and we should write our dataset size. They're all their images, and we should 6 classes, so we write here 6, and activation will be softmax for multiple classes, and sigmoid for binary or 2 classes. So that's the end of our model CNN. Now we should have the compile the model. So we write model dot compile and the optimizer also mentioned here. So we copy from here. So the compile optimizer equal to tf dot class dot optimizer atom. And now we have add loss. Loss will be categorical cross pro cross entropy and matrices will be accuracy. Matrix will be show us to the accuracy. And the last we have model summary. They should give us the summary of the model. Now that's the end of model summary. Now that will be print the model summary. Now we have the history. History is equal to model pet dot pet x equal to xtrend and validation data will be xtest. Now the epochs will be so now we have added a step for epochs, and here we add xtrend dot samples double slash, and we have add batch size here. So we have copy the batch size and paste here. Now we have add validation steps. So they are down validation steps. We add xtest dot samples and the batch size. Alright, now we add callbacks equal to callbacks. So now that's the end. So now we have add the history at the sections. Accuracy is equal to history dot history will be accuracy, and the validation loss is equal to history dot history sm, then validation loss, accuracy, and now loss is equal to history dot history and now validation loss, the first one is accuracy. Now there's a validation loss, that's history dot history, that validation loss. 1 comma 11. We have used data box, so we write 11. If we use 50, so we write 1 comma 51. Now plt dot figure size is equal to 15 cross 15. plt dot subplot 2 plus 2 comma 1, and now plt plot for range and accuracy. Label will be training accuracy. Now we just copy that and paste down here and change the training accuracy. It should be accuracy, and there we write validation accuracy. And now plt legion rc upper right and plt dot title. The title will be training and validation accuracy. That are used for titles are used for titles of the graph. Now we just copy and paste here. There we should write 2, and there we write training loss and validation loss. And there should be something wrong. We write loss, and that will be validation loss, and the upper right will be correct, but in training there will be lower right, and then we write training and validation loss. plt dot show, that should give us the graph. So there's the end. Now we should run the program. What type of error? That should the size, class mode, yeah, there will be special class mode. Yeah, that should be right. Now again we run the program. Now what type of optimizer, that optimizers, and I should write optimizer, spelling mistake, optimizers. Now that's okay. Now should we run type of error. Now there will be error of efficiency. There y, but as e we write y. Now let's check. Oops, again, what mistake model? Oh, sorry, model. I was right. M capital. That's a small. We should correct this. Model and small and small. Now the other is correct. Now we should run. Now again, it's a fork. Okay, we should check. It's a fox. So let's we check fork. There should be a fox, and I was right. Fork. As this letter is missing, so now it be okay. Now we have run the program. I think it should be run this time. First time it will take some time, so don't worry. Now it's our images, it's our model summary. There is our training images, testing images. It should be now okay. There is our first epoch. It will start the accuracy loss at giving the eta is the time. There should be time. It will take some time. It depends on your system. It will, if your system is too fast, like you have good processor Core i7, Core i9, so it will be take less time. I have in my system Core i7 second generation. There is accuracy 0.21, it means 21% accuracy. And there is our model summary. 58, 128 is our total parameters. And the radar showed the GPU. I didn't use the GPU for this, so that gives us error, so it doesn't matter. Now it's our first epoch, the accuracy. Now the second epoch will be start. It goes to the 10 epochs. Now in last it will give us the result like that. That result will be shown last. This is our training accuracy, validation accuracy, training and validation accuracy. And let me show where is it. So there will be the training and validation loss graph. Let me show. There is third epoch. Now I was little explained how it was our model run. This is another model, but let's explain. This was first convolution layer, second, third convolution layer, and fourth, and this is a Latin dense layer, and the last is softmax. Our classes. So there is the input image. It will predict the diseases area, all the images, and that would be run like that. You can show in the image. I will be explain in another video because it will take much more time. It was too lengthy. So this is our first convolution layer, and the second and third max pooling layers all was given, and this is a flat and dense layer, and the last and this is flattened layer, and the last one is a dense layer. and this shows our output. It will shows our cinema would like run, how to like run. Let me show that this convolution makes fully connected softmax for multiple classes, and the filter kernel size are giving that. Now it is 6 Fox accuracy will be 86% something. Now thank you for watching and see you in next part.